Hi, this is Mark from LongIslandWatch.com, and welcome to episode number 5 of Watch and Learn. Today we're going to be tackling water resistance and what it means to your watch, and what it should mean to you when you use your watch in the water. It's probably going to be a two-part Watch and Learn. I'm guessing numbers 5 and 6, because I have a lot to discuss, some pertaining to the watches and then some pertaining to specifications. So, as a vendor, I've dealt with probably 50 to 60 companies over the years, different watch manufacturers, and I will say that water resistance is one of the stickiest wickets out there for warranty service. Most of them, if not all of them, will not cover damage by water intrusion, especially if it's a dive watch. And there's many reasons for it. Whether I agree with it or do not agree with it, really is not part of the conversation. But, from a manufacturer's perspective, they feel that the watches they deliver are always water resistant, at least up to what is specified on the dial, and that generally intrusion of water into the watch is a result of user error. So, water resistance, I'm going to cover really two water resistance marks. The regular mark, which you will see on a standard watch, which so like this Orient here, it just says 200 meter on the dial. You see it at the bottom. Sorry, let me move the hands out of the way. And I'm holding the case back on at the same time. There we go. See, water resist 200 meters. And then also watches like the Seiko 007 that carry the diver's mark. Divers 200M. That diver actually means something. It's also echoed on the case back. It says scuba divers right here on the right hand side. All the watches I'm going to show you are again junk watches, so yeah, I know the backs are open and my gloves are going into them, but we just use these for parts and general instruction. So regular water resistance marks like you saw on the Orient basically just specify a depth. 200 meters, 100 meters, 50 meters, 30 meters. And what that is a depth that they pressure test the watch to. So they'll take the watch, all sealed up, submerge it in a tank, and if it's a 200 meter watch, they will submerge it to 200 meters of equivalent pressure. When you go down 200 meters, 660 feet, the water gets there's a lot of pressure from the water, and they simulate that in a tank, and the watch must hold its water resistance through that pressure for a specified time. Now, if the watch does not carry the diver's mark, which this one doesn't, it actually means that the factory test samples off the lot every so often. Via statistical sampling, they'll measure every couple. Whereas a diver's mark, when you see the diver's 200, that means it's certified to, well, nowadays ISO 6425, which specifies that every watch must be water tested. But we'll get into specifications later. The various numbers, you'll see meters, you'll see atmospheres, sometimes you'll see feet. It's roughly 39 inches to a meter if you want to do the calculation. 3 feet 3 inches per meter. 10 atmospheres is 100 meters, so every atmosphere is 10 meters. Everybody uses a different unit. Metric usually is the most popular. So how do watch companies then seal against water intrusion? Well, obviously they use a series of gaskets and rings. So I'm going to come back to the Seiko. So if you look at the watch case, there's only a few areas where water can come in. It can come in through the crystal, the interface over here. It can come in through the crown, or it could come in through the case back. So the crystal is seated with a crystal gasket, and it's permanent. It's pressed in. It's not meant to be serviced. If you change the crystal, you have to change the gasket. The crown is gasketed, and as is the case back. So I have this rubber O-ring here. And this is what people, are referring to when they talk about the seals of a watch. It's a round cross section, and it fits. You can see. Let me just pick up my tool here. It fits in this what we call a gland. So there's this racetrack that's milled into the case. If you can see it there, when you put the gasket in, a lot of times it's actually stuck on the cover, on the case back. But so here you can see when it's there, it actually sits just proud of the surface by a little bit. And now the theory here is that when you tighten the case back, so here's the case back, you see it's got threads on it, you thread that down and it presses against the gasket, and the gasket fills that gland. So you do this and you tighten it down. I'll talk about this in a minute if you don't know what this is. You tighten it down. As you tighten it down, you'll bring the two metal surfaces into contact with each other. And when they're meeting, I can now do it with my finger, when they're meeting, that gasket compresses. It's solid rubber, so it compresses. It comes down a little bit and it fills that entire gland up. So between the case back and the case of the watch, you have this rubber barrier that's pushing against the case back evenly because we use this nice, screw down case back. You do not have to tighten it like King Kong. Believe it or not, once the two metal surfaces are touching, any more screwing that you do does not make the watch any more watertight. In fact, you could argue that it makes it less watertight because then you can get into warping the cover, warping the case back. So once it's the two sections are mated and it's reasonably tight, you can stop. If your wrench still goes, it doesn't mean that it's not tight enough. It's probably tight enough. I've tried to take case backs off of watches where you have to really use like a 12-inch lever arm to actually get it off. So that's the principle behind gaskets. Now, as I'm loosening this up, whenever the watch is serviced, it is recommended that the gaskets be changed, especially if you have a diving watch. It's just a good idea. They're cheap. It's cheap insurance. It's also recommended that if you don't service the watch, every 2 to 3 years you replace the seals. And that's another reason why watch manufacturers really have a tough time with warranties on water intrusion. Because when they test it in the factory, the watch is brand new. Whether it's an ISO diver or a regular water-resistant mark like was on the Orient. It's brand new. The seals were just put in. The watch was just assembled. No one's been in the watch. No one's subjected it to salt water, corrosive elements, a hot tub shower. And I know people do shower with their dive watches. I don't recommend it. I don't think it's a good practice. Heat and humidity, do have a tendency to go wherever they want. And it's, I don't know, I just find it not necessary. If you want to, that's, more power to you. But I just don't think it's necessary. So then the other place where we can get water in the watch, as I said before, is the crown. Because the crown there's a big hole where the crown comes out. This case tube, you see a screw down? This is a screw down crown. That's where water can come in, air can come in, warm, moist air. So what I'm going to do is I'll just take this crown out really fast. I'll shine a light on it, and you can see right into the case. Likewise, to do a light again, you can just see where the crown tube comes out of the case and where the crown goes in. But the crown itself, if you'll notice, is on the stem is this nice, another O-ring. So this O-ring just squeezes into the case tube. Let's see if I can get it on camera. It goes into the, oops, get out of here. It goes into the case tube. And now when the watch is in, whoops, I didn't see it, sorry. There we go. So now the watch is in setting position, see? But that gasket is inside the tube. It's not out. So the watch is being sealed. So if I had the case back on, the watch would be sealed. The other thing that, when watches are assembled, they are assembled in a reasonably dry environment, not a lot of humidity. If the watch is ever open, a battery change, service, whatever the case may be, if the watchmaker or the area where it's done is not in a really well-controlled environment, now you can get humidity into the case, and that's going to condense out easily later on. Okay, so that's that's how this Seiko works and how it maintains its water resistance. Obviously, the 200 meters is really achieved when the crown is screwed down. That's like I said before, manufacturers say a lot of times it's user error. You dive with the crown open, you dive with the crown out. You know, the watch actually will maintain. I did this before. Maybe I'll do a demonstration in the next video, but if you pull the crown out, don't try this. If you pull the crown out with the case back on, submerge it in the tank, which I did, no water gets into the watch because that seal actually keeps the water out. Now, I didn't manipulate the crown because that wouldn't be a good idea because then you get that seal moving, and once the seals start moving, you know, wiping seals are never a good seal. You know, stuff will get by. But in the static condition, the watch did remain dry. But that's how this Seiko does it, and it's how a lot of companies do it. I'm going to pop this back on here, and then I'm going to bring you over to the Orient just so you can see a difference in another 200 meter, but now we're in a non-diver. Even though it's an Orient, it's a diving watch, it doesn't meet the ISO standard. The gasket is a little bit different. It's still a round gasket, but it doesn't go into a gland anymore. It sits on a ledge here, and it compresses. See, I'm going to try. Sorry about that. It compresses, but it doesn't fill a gland like the other one does. So it's not as elegant of a design, I would say. You know, speaking, you know, in engineering speak. So this Orient also has a crystal. The crystal is protected through a gasket. We've got a button. Now I can't take this button out. I'm not going to take it out, but this is the button for the day advance. But I will take the crown out of this one and show you how this one is protected. So I've taken the crown and stem out, and I look at the crown, and uh-oh, there's no gasket. Don't worry. It's right there. It's in there. I'm going to, again, do the flashlight. It's right at the tip. I hope we can make it seen. Let's keep moving it around. And if you can see it right at the top of the crown tube, there's a black circle. And that is the gasket. So the gasket for this one is in the tube. So that, again, when the crown is out, you're changing the time or the date. Not underwater, mind you, but just in regular, in the atmosphere, in the environment. You're not allowing water to come in, water vapor, warm air. You're not getting any of that in. If you live in Florida, you know, and it's the summertime, and you go to change the time on your watch, and the crown wasn't sealed, you let all that warm air in, and that would be a disaster. Because then when it cools down, it's all going to condense out on you, which I'll get into in a minute. Oh, I wanted to show you this. Some of you probably know what this is. Manufacturer's name is actually wiped off. I think I got this from Ofri. It's a ball. It's a rubber ball. It's filled with air, and you use it to take off screw-down case backs. It takes off a lot of case backs. You basically just push it, and you turn counterclockwise. And you don't have to worry about a tool slipping or anything. Really a nifty thing. I have a couple of them. My kids usually play with one, and I have the other. But you know, if you regularly take the backs off of watches and you're worried about scratching them, you could try this. It does a great job. So, how else do manufacturers, you know, put on case backs, and how do they protect it? There is no doubt that the solid screw-down case back that I showed you before, solid screw-down, this is the best way to protect against water intrusion. I think everyone would agree with that. I don't think anybody would argue that point, because as you screw it down, it's like one giant screw, and every point around the outside is seeing a lot of thread force. It's being drawn down tight, evenly. Now on to another watch. This is an old defunct watch. Actually a very pretty watch. We used to sell this brand. This is an individual screw case back. So the case back goes on like this, and it's held on. Sometimes you'll see them with 4, and this one happens to have 8. So little screws go 1, 2, 3, 4, 5, 6, 7, 8. Same principle. It's got a rubber gasket. You can see it around the lip here. Point to it right there. And it fits again onto a little shelf in here. And as you tighten it down, it compresses. But the major problem with these, if you're an engineer, you know that as you screw this screw down and this screw down, these are just point forces, a point here and a point here. The rubber, which is incompressible, is constantly pressing against the cover. So you actually will get, and it's measurable, you will get a high spot halfway between all pairs of fasteners. You get high spots. You get a high spot here, you'll get a high spot here, you'll get a high spot here. And that's conventionally why, this is fine for regular water resistance. This one is what? 5 atmospheres. So 5 atmospheres, is 150 feet, 50 meters, 165 feet. So this isn't wonderfully water resistant, but it's enough for, general activities. But if you're going to get to the 200 meter mark, you really need this. I do own a watch that actually is individual screws and it's 200 meters. I trust it, but after it was a year or two old, I did not take it in water anymore because I did not get the seals checked. And if you're a true diver, you probably will get your seals checked every now and again. One other thing I just want to discuss, watches with exhibition case backs, such as this one that I've used in the other watch and learns with a lot of parts taken out of it. This is just another seal, the glass window to the outer ring. So that's another thing that has to be sealed for water, and generally a dive watch will not have a see-through case back. A real dive watch definitely will not. Because you want to, how do you minimize water intrusion into a watch? You would make it with absolutely no intrusions. What did Apple do with the iPhone 7? They eliminated the headphone jack. So it's argued that if you could eliminate the crown and a removable case back, you would have the perfect pressure vessel. So oftentimes we'll get customers that say there's condensation in their watch. And I said Florida before, and I'll say it again. If you live in Florida and you come in from the outside into a cool air-conditioned room, your eyeglasses almost definitely fog up. And sometimes, depending on your watch will fog up. I'm not going to say it's normal because it depends on what's going on. But I will show you that condensation can happen in any watch. This is a water-resistant Divers 200 meter SKX 009 that I pulled from stock. It's brand new. I'm going to be using it for some other stuff, but I figured before I did that, I wanted to show you guys something. So if I assume that this was assembled in a relatively cool and dry environment, and I said 68 degrees and 30% relative humidity, which is probably as low as you're going to get, I figured the dew point is around 38 degrees Fahrenheit. So I said, hey, what if I just put a piece of ice on top of the crystal, leave it there, and then take it off? I should see condensation or fog. So I brought some ice with me. So I put some ice on the watch. I'm going to leave it there for about 30 seconds to a minute. Now what I'm trying to do is cool the glass down. And the air inside the watch case, because all air has humidity in it, there's no such thing as totally dry air. The air inside the watch case will get to the cool temperature of the crystal from the ice, and it will fog up. The water should definitely condense out and give you fog on the crystal, and then within a minute or two it should just disappear again and go back to being a normal watch, a normal see-through crystal. So it's been about 30 seconds. I have a paper towel. I'm going to dry it. I'm not doing anything, no fancy stuff here. I have caused this ISO-rated 6425 watch to fog. Just a piece of ice. So yes, you can have fog or condensation inside your watch, and it can be normal. If you were to go outside on a snowy day and you were just coming in from a warm heated house, you would get this. Now as the watch would sit on your wrist and your watch will warm it up, your wrist will warm up the watch. The condensation that you see on the crystal will simply just go back. I'm going to put my wrist right on it to warm it up. Will simply just go back to being water vapor in the air inside the watch, and the watch will be perfectly legible again. There's nothing wrong with this. There's no damage. And the reason why crystals are the things that fog is because it's furthest from any source of body heat. It's on top of the watch. It's away from anything metal. Usually when fog will form on a watch, it forms right above the center point of the dial. And that's because it's the furthest thing from anything metal, and that's what's going to conduct heat. Presto. Clean dial again. Clean crystal. So if you do get condensation on your watch, don't freak out. It may be normal. It may not be normal. If you see water droplets definitely bad. But there is moisture inside your watch. Get used to it. The only company that I know of that really gets around this, and I would be remiss if I didn't mention it, would be Zinn. They put a desiccant capsule in the lug, and that absorbs any moisture that might be in the watch case. Here is one of my Zinns, and you can see it right there, that blue dot. It's kind of like the do not eat packets that you get inside some things that you buy. You take home, you open it up, this little packet, in your shoebox says do not eat. Well, you wouldn't eat this either. It's a desiccant. It's a sulfate capsule of some sort, and it absorbs any humidity that might be inside the watch. And if it turns pink, that means it has reached its maximum absorbance, and you need to get it replaced. Zinn obviously does that. I think that about does it for this Watch and Learn. I'm going to continue hopefully next week with a part 2, and we'll discuss the ISO specifications. I'm going to go over some dynamic pressure, maybe even do some calculations. I did some hand calculations earlier to show that when you move through the water, you really do not create a lot of dynamic pressure on the watch seals. It's a big misnomer on the internet. I used to believe it myself until I did the math, and I was shocked that you had to move 40 miles an hour through the water just to get up to 25 meters of equivalent static depth. But that should be a good one. It's going to be maybe more technical, and maybe you can learn some more stuff about it. So anyway, this has been Mark from LongIslandWatch.com, trying to teach you a little bit about water resistance. If you have not subscribed to our channel, please do so at this time. If you like this video, please do like it, and if you have any questions or comments, you can put them down below, and I'll be sure to address them as soon as I can. Thank you very much.